Okay, hello everyone. Uh, yeah, so first of all, as I was just saying, so apparently there's going to be a strike next week. Um, uh, I'm going to probably announce by email on Tuesday morning whether I'm coming in or not. If I'm not coming in, we'll do it via Zoom. Um, Sometimes hard to tell how these things will develop, like whether they're blocking access to the campus or not. Um, And okay, so that's one public service announcement. Um, the next is just that uh, heads up that the reading for next class is kind of long, so um, it's several different things. So if you want to do it all, you might want to start early. Okay, so now on to chapter 10 of Logic of Scientific Discovery. Um, so you might wonder what we skipped. Now, actually, since I always skip it when I teach this course, it's been quite a few years now since I've read the stuff we skipped, but it's mostly technical stuff about probability, um, plus some stuff about quantum mechanics. Uh, and I will mention the important point about probability, but a lot of it, I mean, I don't know how much of it actually works. I think I know Popper is not like someone who usually hears cited on things like this. Um, I don't know how much of that is because, well, because the thing is, like people from the other school, from the other side of things, also didn't get things right. Um, right. I mean, remember the stuff about verificationism and how they had kept having to change the definition because it didn't work, and there was a lot of stuff like that. Um, so I don't know if Popper isn't cited because he there's mistakes in this, or because it's only interesting from his point of view, or it's because people just don't like him, or what. Um, anyway, it's that stuff is not really important for this course, I think. Um, all right, so in chapter 10, um, the issue here, roughly speaking, is um, how why and or in what sense does science make progress? Um, so, I mean, this is both a very important question for Popper to answer in his uh, debate with the inductivists, um, but is also going to be like a big issue between Popper and Kuhn. So, so it's important. I guess you could say even more broadly, what is science good for? Um, why should we do it? Um, and you expect the answer to have something to do with the demarcation criterion, right? Because if not, then the demarcation criterion looks like a bad proposal, right? Like, I mean, the demarcation criterion should, if science is good for something, the demarcation criterion should pick out exactly what's good for that thing. Um, uh, Otherwise, it's misleading at best, right? Um, Okay, and the problem here for Popper is that the verificationist slash inductivist slash justificationist view seems to have a really good answer to these questions about science, right? So that like the main point, according to these people, is that science accumulates empirical facts. So, because we record our observations and we hopefully don't forget them later. So as time goes on, we have more and more records of observations. We have more and more data. Um, and the more facts we have about different things, um, the more, well, two things, the more justified our theories become and the more universal they become. Or rather, I guess it's really like that is for a given level of universality, the theory becomes more justified. And for a given level of justification, it becomes more universal. So we have more universal theories that are just as justified as our old ones were. And meanwhile, our old, more specialized theories become more justified than they were before. Yeah, I mean, I've mentioned this point several times, but I think I'm going to come back to it again, the question of what more universal means. Because again, like any statement, all these any statement like this is just as universal as any other statement like this. I mean, there can be there's first of all, there could be the difference if we can really make sense of it that Popper calls the difference between strict universality and numerical universality. Or again, in German, it's actually specific and numerical universality, but change it to strict universality in English. Um, and also there can be restricted quantifiers, like implicitly restricted, like the quantifier only goes over a certain small set of things or whatever. But if you don't have those, that if you don't have either of those, then all statements like this are just as universal as each other. What does it mean more universal? But if we start with a certain theory, um, and we have a new theory that implies everything that the old theory did and more, then you can call the new theory more universal. So it implies more. But of course, you have to be careful about how you do that, right? Because suppose you have two theories, S and T. And you can think of a theory as just one very long sentence, as long as it's finite anyway, that will work. Right? You can just take all the things that you thought of as axioms or whatever and put them all together with and you have a very long sentence, and that's the theory. Right? So we have these two sentences, S and T. Well, so here's a new theory, S and T. Right? Again, this is how I write the logical operator in. This is also a theory. It's an even longer sentence. It's the conjunction of these two sentences. It implies everything that this one implies and more, also what this one implies. And vice versa. So you could say, oh, we have a more universal theory. We started with these special theories and now we have a more universal theory. But obviously, you wouldn't want to call this a more universal theory, right? It just says exactly what the old theory said. um, and just like uh, generally speaking, it's too easy to come up with more universal theories if that's all you require is that it implies everything the old one did and more. So what you want is for it to imply more than the old theory with the same or fewer resources, so to speak, right? Like you want more implications per unit theory. And this is why Popper, and uh, again, a lot of what we skipped, or part of what we skipped in the book is about this. And this, I think, the way Popper tried to do it in this book, at least, turned out not really to work. But uh, this is why Popper spends a lot of time talking about what makes a theory simpler than another theory, right? Because that's the way he tries to understand, well, both of those things in relation to each other. What being more universal means is being simpler and implying, or yeah, implying more. Being simpler means implying more for what you start with, so to speak. That's the way he tries to define it. He also says that that makes the theory less probable. Um, this is, well, maybe I'll come back to that. I mean, there's an appearance of disagreement between Popper and the inductivists about what is more probable and what is less probable, but it kind of seems like they're talking past each other. Because, Popper by less probable means like less probable if you don't know anything, basically, right? Like it implies more, so it's less probable. Whereas the justifications are talking about how probable it is given what we know. So, I mean, it's true. Popper says given what we know, that is given our data, no theory ever becomes more probable because of that. And so that whole subject is like empty according to him. They're none of them are probable at all from that point of view. But still, there isn't really a disagreement there about what. Anyway, um, right. So that's roughly speaking what more universal has to mean, right? A more universal theory is a theory that um, implies what the old theories did, not by just saying what both the old theories said, but by saying less that implies them both. Um, and um, and I think this is actually the same as what I said when I first talked about what Popper means by more universal. Because remember, like ideally, according to Popper, these theories will be arranged in a system. So there'll be like the most universal part at the top, and then there'll be less universal parts, and then we'll get down to the basic statements at the bottom. And so uh, the statements at higher levels of this system are going to be more universal in the sense that they're farther away from the facts. And that will be because they're simple theories that imply all the complexity that you find farther down. Um, and when you come up with a more universal, well, this is the axioms, so when you come up with a more universal theory, you still have just a few axioms up here, and now you've got all of this and that. And you've got farther away from, right? That is, the old axioms are going to be implications of the new axioms. You're going to be able to ride the old axioms to the new axioms. Or Popper says, at least a good approximation. Right? That is, the new theory is going to at least imply that the old theory was more or less right. Okay, so I mean, that's what we mean by more universal. Now let me go back to talking about, because I'm kind of veering off into talking about Popper's view. To go back to talking about this, right? This is the justificationist view. So the justificationist view says, as we accumulate more facts, those empirical facts, right, on the one hand, they will supply more and more support for our old theories. And so just because that's because we have more facts about the same thing that we were talking about before, but we also get a wider range of facts. And so the facts will start to support more universal theories. Um, Now, I mean, of course, there can always be a catastrophe in which, like, all of a sudden, all our new data doesn't support any of our old theories. Um, but again, according to these people, so when we say the theories become more and more justified, that also means they become more and more probable. We should believe them more and more. It becomes rational to believe in them to a higher and higher degree. That's what both justified and probable are supposed to mean here. So by definition, that kind of catastrophe is improbable. That is like incredible in the literal sense, right? Like that is you shouldn't believe it's going to happen. You should believe only to a very small degree that it might happen. So this is good, right? As you know, barring some really improbable events, we're going to get more and more support for our old theories. And also, we're going to get support for new, more universal theories. Um, and, because the justification makes the theory more and more probable, that means we're making progress towards knowing things about the world. I mean, not knowing things for sure. Uh, Again, that's something that the justificationists have to concede almost immediately. Um, and as I pointed out, Carnap really concedes that in the Aufbau too, even though technically in the Aufbau, all my experiences together make the correct theory 100% certain. Um, that's only subject to various fictions. So, right. So we're not making progress toward knowing absolutely for sure what's true about the world, but our beliefs about the world are getting more and more probable. Um, and probable really means like, well, I don't know if I should say really means, or maybe I should say originally means. I mean, probable means believable in the sense that you not in the sense that you're able to believe it, but the sense that you should believe it, or you do believe it at least. Um, then, like the mathematical theory of probability is an attempt to make sense of that, like give rules for that. But and uh, um, inductive logic is an extension of the mathematical treatment of probability, is a version of mathematical treatment of probability. So it also is trying to give you rules for exactly like what your degree of credence you should give a theory, given a certain amount of evidence. But leaving the details of that aside, the point is it becomes more and more rational to believe the theory is true. So we should believe that it more and more strongly that is true. Um, so we should be happy, right? We're getting more likely to be right about the world. And this, of course, would explain why science is useful. It gives a good answer to the question, what is it good for? Because obviously knowing what is more probably true about the world is really useful. Um, um, because it can be a good guide to future action. Uh, so like, let's say we have a theory of um, climate change that predicts that if you do this, this will happen to the climate. And if you do this, this will happen to the climate. And you're trying to decide which of those things to do. It's great if the data are, making your theory more and more probable. So it'll tell you more and more with greater and greater degree of certainty, which of those options is better. Um, and this also makes it clear why we should want to do science because it's useful. Um, so, because it improves the lot of mankind. um, okay, so like as I said, the problem for Popper here, or the beginning of the problem for Popper here, is that the justificationist seems to have a really good answer to these questions. Why does science make progress? How does it make progress? Why is it useful? Why should we do it? Um, but I mean, so obviously, like on the negative side, Popper thinks, or Popper says, well, yeah, that would be a great answer, except it all depends on the idea that accumulating empirical facts makes a universal theory, can make a universal theory more probable. So that it would be more rational to believe it because you have more and more facts that support it. And right, where by facts we mean empirical, that is singular evidence, observations, statements, data, experiences, basic statements, something like that. And so, like, Popper has argued, well, number one, this is not a logical truth. That is, no amount of uh, singular statements can imply that a universal statement is probable to some degree, logically. That is, there can't be a contradiction between there being lots of empirical data supporting a theory and yet the theory being probably false. Um, I mean, remember that's kind of the second stage, right? The first stage we just say there's no contradiction between the theory being false and there being lots of data that supports it. I mean, that's pretty easy to understand, right? The theory says, all swans are white. You can have observed a million swans that are white, but there's no contradiction in supposing that the next one will be black. Um, but Popper said, but at that point, people will say, oh, yeah, but it's improbable that the next one will be black. And Popper says, well, no, I mean, the statement of the theory is that a universal theory is probably true is itself a universal theory that needs justification. Um, I mean, how to understand that depends on how you understand probability. And again, that's part of why Popper spends a long time talking about probability in this book. Um, um, but I guess you can put it this way: probability could be something that by definition increases when you have more evidence for the theory. Um, but in that case, it's consistent with the theory being very probable that it almost never makes the right correct predictions. So, like, if you want probability to be useful, you have to say that probable theories frequently are right or something like that, and then there's no contradiction. It's not clear exactly what the right way to think about this is, and uh, I think you know outside of the specific context, it's very hard in general to understand what probability is supposed to be, right? So, uh, but I, but it seems Popper is right to say that the view that evidence makes a theory more probable is not in better shape than the view that evidence makes the theory certainly true. Um, so, um, right. So Popper says it's not a logical truth. There's no contradiction. But it can't be empirical. It can't be empirical either in the justificationist sense, because then it would be circular, right? That is, if I'm going to say, why do I think that more empirical facts supporting a theory make it more probable? Well, it's because of this empirical theory that says that facts make a theory more probable, right? So, like, for example, because I've had lots of experience of theories making correct predictions after they were supported by facts, then that's going to be circular or infinite regress, depending how you look at it. I guess Popper says infinite regress. He says you need another principle of induction to support the principle of induction you're trying to establish. Um, so, but it also can't be empirical in Popper's sense, because we can't allow a failed prediction to ever falsify it. Um, because otherwise every failed prediction ever would falsify it, basically. Right? That is every time a theory that had evidence to support it failed, that would be a counter instance to our theory of induction. That's what it would mean to make it empirical in Popper's sense, right? We would have like theory of induction up here. Down here, we have the theory we're testing. And here's the statements we're using to test this theory. And the theory of induction plus the initial conditions, that is, plus all the observations we already made, imply that this theory is mostly going to make true predictions. So then we find that this theory makes a false prediction. So at least if we find that enough, we have to guess how much is enough or something like that. If we found that enough, we're supposed to reject this theory. But if we reject this theory, we're supposed to reject this theory. So the theory of induction that's empirical in Popper's sense would be falsified every time we falsify an inductive theory. Are there questions about what I just said? Because people are looking. Okay.
I mean, like when we falsify a lower level theory, theory.
Right, because again, we're looking at the principle. Maybe I should call this the principle of induction. We're looking at the principle. So, like, we've tried three alternatives here. The first one is that the principle of induction is a logical principle. Popper says it evidently isn't. There's no contradiction in supposing that well-supported theories turn out to be false, bad methods of prediction. So it's not logical. Well, so then B is empirical. It's not logical, it must be empirical. Because Popper again says that synthetic a priori in German, he calls the idea of a synthetic a priori principle an Unbegriff. Right, the Griff means concept. So Unbegriff means like a non-concept. Right, I think it's a way of saying like it's nonsense or something. That seems stronger than what he said about Kant before. But Anyway, it's possible he thinks the idea of a synthetic a priori has been falsified. For example, by Einstein. That seemed to apply only to a particular type, right? That is because general relativity has falsified Euclidean geometry. So it turns out that it wasn't synthetic a priori. But
Couldn't there be new synthetic? Or maybe we just were incorrect about what it was.
yes, that is what some Kantians said
Yeah, I don't know.
in
That's
response.
like you haven't falsified physics just because one physical theory is wrong. I know that's not really the same,
But it's, I mean, it definitely, it requires you to really rethink Kant's argument for the possibility of synthetic a priori.
Einstein, I think he disproves of synthetic a priori. Because if anything, I would think he seems like he might have been sympathetic to that idea. He
Yeah,
was
he might have
sympathetic to the idea that there's like a prevailing order of the universe.
Yeah, well, I mean, almost everyone is sympathetic to that somehow. But no, I think I mean, if you just look at the methods he used, I mean, so like Popper is so impressed by his willingness to put his theory to test. And that's true. His theory did make predictions, but on the other hand, he worked so much with like thought experiments and um, kind of principles that he thought that if you really thought about them, you would realize they had to be right or something like that. So yeah, I don't know what Einstein himself has had about say about this. There's also a TikTok that my kids are into at this point about blood Einstein, something like that. Anyway, see, you guys probably are are you guys up on TikTok trends? No. Yeah. See,
I'm gonna reveal something I think they've tried very hard to keep secret, which is that Connie loves TikTok. Connie loves German TikTok.
oh, German TikTok. I don't think my kids watch German TikTok. Anyway,
Pudding McDouble.
what?
Do they know about Pudding McDouble?
No. But they did tell me that I should not make any 6-7 jokes because they said 6-7 is so old. And I look like an old weird guy who's out of touch.
I really love the fact that people can just decide to make a number funny, and really you can do it with any number and it works. I think, and people have done it throughout history. I think that's philosophically great. I think we should write an analysis of that. If I start saying 23 often enough, it'll get funny.
I mean, I wouldn't push your luck. It might get old after a while, but there is something weird about that. Why? I mean, but is it specific to numbers or is it true of anything you keep saying, randomly saying?
I guess it's kind of true of anything, but like numbers have, or they seem to have, a kind of greater degree of arbitrariness, I think, than almost anything else in language. Because like they're pure generality in theory, which makes it funnier.
And yet they're incredibly specific. That's what's weird about them, right?
You
Like
have
the
6 or
number
7 of anything.
you can, yeah, but 6 and 7 are different from all other numbers.
Yeah, it's true. But every 6 is the same as every other 6.
Yeah,
even though
I don't know.
6 of a different thing.
Anyway, this would be a good topic for a different course, maybe. I don't know. Anyway, so getting back to this, so right, I got onto that only because yeah, the videos, and I feel like there might be something racist about it. That's why I'm a little hesitant. So like, what? Yeah, yeah, but
Oh, is it those ones where it's like an AI voice and it's like if Einstein was from, and then it names a country,
no,
he wouldn't
no,
do this, he would do this?
no,
I get a lot of it, like if Thanos were from Armenia.
No, no, it's not that. Anyway, all right, let me go back to this. So, right, so we've ruled out logical. Synthetic a priori is no good. According to Popper. And you know, he doesn't say anywhere, as far as I know, because general relativity falsified it. I'm just guessing. I'm not aware of anywhere he says exactly why he thinks it clearly that idea clearly failed. But in any case, so that's out. So we're left with, so if it's not logical, it should be empirical. And we're talking about the principle of induction here, right? So the first thing, so what does empirical mean? So the first thing is we tried that it's empirical in justificationist sense. That would mean that it's derived by induction, right? That's what inductivists or justificationists think empirical theories are. How we know they're right. Because, right, this has to be a theory that we think is true, or else it's not going to help us. The principle of induction, and we have to think it's true. Why do we think empirical theories are true according to justificationists? Because they're supported by induction. And again, that's obviously circular or regress, right? The principle of induction is going to be supported by induction. So then you said, well, no, maybe the principle of induction itself should be regarded as empirical in a falsificationist sense. So then it wouldn't be supported by induction. So it's not circular, but then you have to look at it this way. It's a guess, right? It's a bold hypothesis that induction will work. And then these individual theories, and it's a theory something like any universal theory, right? It says, like, you know, for all x, given some initial conditions, something follows. Only now the initial conditions are, given that all your old observations supported the theory, what follows is the new observations will probably support the theory, or something like that, right? That's what the principle of induction is going to look like. So, so down here, the individual theories are, you know, going to be derived from the principle of induction, plus the old observations that supported them, right? So like, if why should I accept the theory that all swans are white? Well, because I have this bold hypothesis that theories, well, that is because all the swans I've observed so far are white. Let's say that's not true. I've seen black swans, but never mind. Because all the swans I've observed so far are white, that's the initial condition. And according to my bold hypothesis, such a theory is going to be a good predictor of future swan observations. That's the way this alternative would work. And what Popper's point about this is that you couldn't look at it that way because that is, you couldn't subject the principle of induction itself to falsification in this way, because that would mean that every time you were wrong about a theory, that would not only falsify the theory, but since you accepted the theory based on the observations and the principle of induction, it would falsify the principle of induction. And and since whatever the principle of induction means, it doesn't mean we never form false theories based on insufficient evidence or whatever. This, you know, the principle of induction would be constantly falsified if that were why. So Popper says it can't be that, it must be a metaphysical principle. And maybe I should have left synthetic a priori to discuss here because you know, one way of understanding what a metaphysical principle is would be to say it's a synthetic a priori truth. So it's not empirical, but we know it's true. But again, Popper says no, that's ubiquitous. So, what does that leave? And basically, it leaves that it's practical. And this is what I ended up saying before about the principle of induction, according to Popper. What you really have to look at it in the end as a proposed set of rules for the game of science. These observations can't force us to believe the theory is true or even probable, but we can make it a rule that we accept the theory based on how many observations support it. That is, we can make that our form of what in this chapter Popper calls, wait, are there two P's in a phrasing? There must be. Someday they'll invent a blackboard with a spelling checker. All right. Okay, good. All right. So it's a form of appraisal, or in German, the word that's being translated is Urteilung. Urteil means judgment. But Urteilung means judgment or something like that. Yeah.
So I'm curious about, I'm curious about the like practical implications of this view about scientific theories, because I know Popper quite justifiably, if you look at like history of what has happened in the application of such, is like very negative about the attribution of scientific certainty to political or ethical theories, part because he doesn't really think there's such a thing as scientific certainty. And like if okay, how do I make this a question that makes sense? Sorry, the question's in my head, but it's not in words. Right, like if theories adopted are never really true, they're just not yet proven false. And it, like, therefore, I don't know if he acknowledges this, but it seems as if conceivably there could be other theories that contradict your theory, but neither of them has been proven false yet, right? It seems as if it has implications for the degree to which people are entitled to act on the world in the name of a true theory. And I wonder if, I wonder how much Popper has thought about that. Like with climate change, right? Climate change is a space where a lot of scientists and people who at least think of themselves as advocates of the method of science are like, this theory is very, very true. We know it's true, and whatever contradicts it is false. And it's important that we take political action on that basis. Right. And if you're like a hardline Popperian, you're like, well, maybe.
So I mean, that's I'm trying to get to that. That's, I mean, so like it's correct that Popper is worried about claims on behalf of ethical or political theories that they're science. But it's not true that Popper thinks that we shouldn't act based on our scientific theories. And yet, it seems there's going to be a problem explaining why we should act based on our scientific theories, whereas, and that's why I chose the example of climate change, right? Whereas according to the justificationists, it's clear why we should act on our scientific theories. They're made probable by the evidence, and therefore we should act on them. So, I mean, that would, I mean, like, assuming we otherwise know how to act. I mean, like, information by itself doesn't necessarily tell you how to act, but it's very useful if you're trying to decide how to act, right? So, like Popper has a problem of explaining that. So, but what I was saying, first of all, is like Popper's first answer to that will be that yes, justificationism has a good answer to that if you give it this principle of induction. But the principle of induction is not a logical principle, not an empirical principle, not synthetic a priori. So we have to look at it in the end as just a proposed set of rules for accepting theories. And that doesn't give you an answer to why we should act on science, right? If you look at it that way. It makes the question, it just raises the question, so are these a good set of rules? Are the set of rules useful for something? And that remains to be shown. Whereas if the principle of induction were, let's say it were a logical principle, then it would be clear why we should adopt the rules of justificationism, because the rules of justificationism would be rules that preserve truth. Just like the rules of deductive logic. They would be part of the rules of deductive logic, right? So if we're interested in reaching true conclusions, we should adopt these rules as to what conclusions to accept. But and similarly, if we're empirical, you could tell the same story. Tatus mutandis. Whatever. Anyway, so mutatis mutandis. All right. Anyway, so but if it isn't any of these things, all we have is a suggestion that with these reuse these rules, and the justification is in at least as bad a position as Popper. So like that would be Popper's negative response here, but Popper still, I think, owes a positive response, right? Because again, if my business is to, supply natural gas to power plants, and you come and tell me, I'm sorry, but you're going to have to go out of business for the good of humanity, I'm gonna want to know why I should believe that. At the very least, before I act on your suggestion. Right? So it's not going to be enough to say, like, oh, the justificationists can't do any better. I'm going to say, well, and you guys go try to do better. Meanwhile, I'm going to keep my company going. Right? So the question is what Popper can say in place of this. So there's an addendum at the end of the chapter. So the addendum was added at the time of the second edition, I guess. So does it say on the addendum when it was added? Oh yeah, addendum 1972. Well, and I mean, okay, maybe before going to the addendum, I should just say, all right, so Popper says in the body of the chapter at great length, I mean, so I didn't even assign all of the chapter, right? So, you can read more about this if you read the whole chapter, but oh, such a bad spelling in several languages. All right. So Popper says, well, it's not about justification, it's about corroboration. Now, this, like, when you hear this, you're like, oh, this is just going to be justification coming back under another name. And of course, he's aware that that's going to be a reaction, right? Like he tries to explain why it isn't. And by the way, the German word that's being translated as corroboration is Bewährung, which actually has the word true in it. Right? Like you might think this would mean verification. There's a long footnote where Popper discusses how this should be translated to English. That Carnap suggested confirmation and he had his doubts about it, but then he thought, well, words don't matter. Let him translate it however he wants. And then he says, which is interesting, but I was mistaken. Words did matter. And so now I want to translate as corroboration. What corroboration exactly means, I'm not sure. I mean, like what it ordinarily, corroboration in English ordinarily means that like someone else's story matches up your story or something like that. It doesn't exactly seem to belong here at all. In any case, maybe Popper thinks this is a better translation precisely because we're not sure what to make of it in this context. So we have to try to figure out what he means. But the idea is that a theory is well corroborated if it has passed severe tests. So, I mean, um, okay, actually, I'm going to go back and so this is what we're going for. We're going for the idea that the way science progresses is that it comes up with theories that have passed more and more severe tests. Then we're going to have to explain why we should act on those things. Or just more generally, why we should want theories that pass severe tests. Like, what is that good for? So, so in response to that, in the addendum, Popper breaks down the problem of induction into parts that are going to allow him to explain. They're allowed to separate out the answers to these different questions about science and give his answer to each one of them. And like, again, I think the strength of justificationism, if you can make it work, is that all of these questions basically get the same answer in justificationism. You answer them all together, but Popper has to treat them separately. I think that's right. So, so there's basically in the addendum, this is confusing because there's 6 numbered points in the addendum, but there's really only 4 versions of the problem of induction that he discusses. Not all the numbered points correspond to a new version of the principle of induction. So the 4 problems he discusses are the logical or methodological problem, and by the way, the addendum is quite different in German. I'm not going to go into all the details, but it's also, I'm not sure which is the original in this case, since it's from 1972. So there is a German edition of this book that has all the stuff that's in our edition. What I'm not sure is whether he like updated the book completely in German and then translated it to English, or updated it in English and then translated it back into German, or kind of wrote them side by side. So I'm not sure which is the original, but I can say that in this addendum, the German version has a lot of interesting differences. But anyway, as far as what it says in English, there's a logical or methodological problem. This is basically what we would usually call an epistemological. Epistemological problem. No, it's not. All right. So, secondly, there's a metaphysical problem. These are problems of induction. And thirdly, there's a pragmatic problem. This, in German, he calls this a practical problem, which could be a significant difference. Why he chose to use the term pragmatic in English, and praktisch in German, I wish I understood. And then fourth, there's a psychological problem of induction. So, the logical problem, he actually breaks down into two parts, I think. One is, one is justifying theories. The other is justifying theory preference. It says preference. It's supposed to. That is, one epistemological problem is, how can induction rationally justify a theory? That's kind of the like standard formulation of the problem of induction. Popper's answer to this is obviously going to be it can't. Right? So he gives a negative solution to this part of the problem of induction. But this problem here, I call it justifying theory preferences, like how can we rationally justify preferring some theory at some time to other theories if what we care about is truth likeness or verisimilitude? Right, Popper says verisimilitude rather than truth because we may never have a theory that's true, but hopefully we can make sense of the idea that some theories are closer to the truth than others. Whether we can make sense of that or not is, again, a difficult problem, right? Like you might say something is either true or it's false. It can't be like more true, right? Like one false thing is not less false than another false thing. They're both just false. So like to make sense of the similitude part is not easy. This is another thing that Popper tries to do in various ways in this book and later. But I mean, at least just in a common sense way, we do believe this, right? Like what I just said about if something's false, it's false. Like we don't really, that's not the way we really treat false statements. We think some of them are closer to being right than others. So how to make sense of that is another question. But so anyway, so the question here is, assuming what we care about is verisimilitude, we want our theory to be true or like the truth. Anyway, assuming we want our theory to be like the truth, similar to the truth, how can we justify preferring one theory to another? How can it be rational to prefer one theory to another? The metaphysical problem is, are there genuine regularities in nature? Right, that's what he's calling the metaphysical problem of induction. So it's a metaphysical problem. I think it's clearly a metaphysical question. Are there genuine regularities in nature? Right, like, I mean, certainly the theory that there are genuine regularities in nature is not falsifiable. Does everyone see why it's not falsifiable? What?
I can't see why. It's,
Oh, well, because,
that's only a joke.
oh, okay.
It's not,
Oh, all right.
it's not possible.
Okay, I'm not sure what that meant, but it was a joke. Anyway, right, so this is definitely a metaphysical question. It can be called a metaphysical problem of induction because you can say, like, what is it we're really asking here? We're asking, like, is it true that, what happened in the past is going to be similar to what happens in the future? Even if we may never figure out the right way of describing what happened in the past to make good descriptions, is it metaphysically true that there is a way? Right? That would be saying that there is a genuine regularity in nature. So that's the metaphysical question. The pragmatic or practical question is it rational to rely on the theory that we prefer? Right, so here the question is it rational to prefer it? But here the question is, given that that's what we prefer, is it rational to act on it? And I mean, you might think that these are the same, but again, remember, here the question is, here what we care about is verisimilitude. So it's like, it's not exactly the same question. It might be that there's a certain way of preferring theories that would make sense if what you're going for is verisimilitude, but wouldn't make sense if what you're going for is correct action. Right, like just thinking of Descartes' example from the discourse, where he says, suppose you're lost in the middle of a forest, what should you do? Now, I mean, in real life, if you're lost in the middle of a forest, you should stay where you are. But that's because you're assuming someone's looking for you. Right? But assume you're lost in the middle of a forest and no one is looking for you. So now what should you do? And Descartes says, well, you should just choose a direction and walk in that direction. And you should, after you make that decision, you shouldn't change your course for any slight reasons. So, like, from a point of view of verisimilitude, that's probably not right. Like, the way to increase your chances of being closest to getting out of the forest is to stay where you are, because you don't know which direction out of the forest is in. But Descartes says, from a practical point of view, you should just choose. Even if you have no basis on which to choose, you should choose something and act on it. Because that way, Descartes says, at least you'll end up somewhere else. And it's probably going to be better than where you are now because you're lost in the middle of the forest. Right. So, so that shows how these questions could come apart. And how maybe arguably they always come apart. I think that's what Descartes thinks. And then finally, you have the psychological question, psychological problem of induction, which is, why do we believe that this theory is reliable? why do we believe that it's true to a certain degree, and why do we believe that it's reliable? Those, I guess are two psychological problems. Um, so like I said, Popper gives a negative solution to this. He gives a solution to all of them, but this one gets a negative solution, meaning it's the solution to the problem is that it's a bad problem because you can't justify theories this way. So, and right away, that seems to come to that seems to run into a contradiction with the fact that science makes progress. Like, remember, I said at the beginning of the course that's what astounded philosophers and continues to astound philosophers about modern science. That unlike philosophy for all those millennia, we tried our hardest to figure out what the world was like and so forth. We didn't really get anywhere. We're still arguing about the same things. Science, all of a sudden, like we know all this stuff and we can do all this new stuff, and it's really surprising. So, but ruling this out, we're saying, our theories are just guesses. We're trying to falsify. And I mean, the inductivist is going to say, yeah, and you're likely, if they're just guesses, you're likely you will falsify them. You shouldn't just be guessing, you should be relying on the evidence. But Popper says the evidence won't help. So you have to guess. And when they're falsified, we guess again. So why should we make progress? And if we do make progress, what is it going to be progress in? And that's what makes the other problems, or some of the other problems, suddenly seem really bad. Right? Like it seems like our reason for preferring the theory that we quote unquote accept has nothing to do with truth, because we admit it's just a guess. So whatever accepting means, doesn't seem to mean believing it's true. This, this is how the psychological problem comes in here. I mean, if Popper were Hume, and Popper, I guess, doesn't understand Hume this way. Remember, we've seen like several Humes now. I think Popper's Hume is closer to Quine's Hume in that Popper's Hume has a problem that he can't solve. Real Hume, Goodman's Hume thinks there is no problem, or I solved the problem. Real Hume thinks there's a problem. Real Hume means my Hume, obviously. Real Hume thinks there's a problem, but there's no point in trying to solve it because we're going to believe, right? As soon as we stop thinking about it, we're going to believe in the external world. We're going to believe in causality. And we can explain why, but the explanation itself, like Hume doesn't accept himself from this, right? That is, as soon as he stops talking about why we shouldn't believe in causality, he starts using causality again, right? Like as a causal explanation of why we believe in causality, basically. Right. So, but so in other words, Hume, I think, sticks to his guns in the sense that he says, like, skepticism is logically unassailable, but we can't believe it. We're stuck not believing it. But Popper, although he agrees agrees, and this is gonna be the solution to the psychological problem of induction, agrees that we always do believe that our theories are probably true, still wants to maintain for himself the privilege of always saying, but we don't have any grounds for believing it. So anyway, the question is, getting back to these problems, that it seems that our reason for preferring the theory has nothing to do with truth of verisimilitude, or with real regularities of nature, if there are any. There may be real regularities of nature, but how are we going to get them by guessing? It seems like if we do believe in them, we're irrational. And that Popper is kind of at the same time saying we're going to believe in them, but telling us not. And finally, it seems like it would be irrational to expect them to be useful. So, I guess in a sense, I've added my own problem of induction to here that Popper doesn't list. Problem of why science makes progress. But what I've said is that, first of all, it's hard to understand. Once we give the negative solution to this, it's hard to understand why science makes progress. And it also seems like if science does make progress, it won't be in a way that's relevant to this, or this, or this, or makes this rational. Okay, so now I'm going to go back and talk about corroboration. So, because Popper, first of all, agrees that science does make progress. And moreover, he agrees that science makes progress in something like the way the inductivists think it has made progress. Right, so he quotes this long thing. This is on page 250. Well, it's not in quotation marks, actually. But it's all in the mouth of the verificationist or justificationist. Right? It starts on page 249. It is quite true, they say, and the rest of the paragraph is all what they say. It is quite true, they say, and even trivial that we cannot know for certain whether the sun will rise tomorrow. But this uncertainty may be neglected. The fact that theories may not only be improved, but they can also be falsified by new experiments presents to the scientists a serious possibility which may at any moment become actual, but never yet has a theory had to be regarded as falsified owing to the sudden breakdown of a well-confirmed law. Now, I mean, you might say, well, right, aren't there all these old theories that we've abandoned? So this is what they say. This is on page 250. The old theory, even when it is superseded, often retains its validity as a kind of limiting case of the new theory. It still applies, at least with a high degree of approximation, in those cases in which it was successful before. Right? So what the verificationist is saying is, we have an old theory. By definition, it made lots of successful predictions. That's why we accepted it. Now it's going to be superseded by a new theory. But the new theory had better make all the same predictions that the old theory did. I mean, or at least it shouldn't contradict any of the old predictions. Because otherwise it will be wrong. Right? That is, the old predictions were successful. So the new theory has to back up the old predictions. Now, to a high approximation means, I mean, I think you might think that means it doesn't really have to back up the old predictions, but I think it still means it has to back up the old predictions in the sense that it has to mean that if we measure as accurately as we measured before, the old theory will be right. We'll only get a disagreement with the predictions of the old theory if we increase the accuracy of measurements. So it really is, again, that the old successful predictions, as they have to be, are like still backed up by the new theory. It's only new predictions using a higher degree of accuracy that are going to be different. Or predictions about things that we just never tested before. Those are going to be different. That's fine. So, right, I mean, here we're thinking about, I think, especially thinking about the theories of relativity and quantum mechanics superseding Newtonian mechanics. And this person says often this happens, but I mean, we'll see Kuhn discussing a lot of other kinds of examples where it's not clear that this happens at all. And Kuhn is also going to disagree with this analysis of this example, but, you know, so like, suppose you want to predict the orbit of a satellite. So you can use Newtonian mechanics. And if you don't need to be extremely precise, Newtonian mechanics will give you the right answer. But suppose you do need to be extremely precise. Like, let's say that this satellite is GPS satellite. You need to know exactly where it is. So then you have to use general relativity. And in fact, there are relativistic corrections that they use, right? Like the GPS system wouldn't work right if general relativity were wrong. But you know, that degree of precision was not something that anyone ever attained in the time before Einstein. Right? So like none of the old observations contradict this. And similarly, like, you know, if you have a binary pulsar, like two neutron stars in a tight orbit around each other, and you want to predict how this orbit will evolve over time. So in that case, Newtonian mechanics gives you the wrong answer, because this system emits gravitational waves and it loses energy to gravitational radiation, and only general relativity predicts that. So, you know, so in this case, Newtonian mechanics will give you grossly wrong predictions, but no one ever observed a binary pulsar and tried to account with it using Newtonian mechanics. So again, all the old observations are still good. It's only these new cases. That's what the inductivist says is happening. And so, and it's because science progresses by accumulating facts. We just add more and more facts. The old ones are still there. So we're naturally going to get theories that back up the old theory within its realm of application, that is, within the realm in which it was actually tested. And also make new predictions about new realms. And again, I'm including the difference in accuracy in this difference between realms, right? Because the observations in here were low accuracy, whereas some of the ones out here will be higher accuracy. So, so Popper says, sure enough, the evolution of theories is something like this. But what happens is not that our theories become, um, well, I guess I should say one more thing. So that's the sense in which we can say, even after this theory is superseded, the new evidence still supports it. Right? That has become better justified, even in being rejected, because we now realize it should be limited to this realm. And within this realm, the new evidence will continue to support it. Unless, except the very improbable catastrophe where the new evidence contradicts the old evidence, right? But that's never been known to happen. So that possibility can be neglected. So, right, that's the inductivist account. So Popper is going to say, yes, I agree. The old theory or some approximation to it does, at least usually, get a better and better appraisal as time goes on, as more evidence comes in. And at the same time, a new, more universal theory that includes this one as a limited case also gets a better appraisal as time goes on. But the appraisal is not justification, the appraisal is corroboration. And Popper says that he meant this German term to be kind of neutral between different kinds of appraisals that you could do. That is, he meant it to include both the justificationist version and his version. So, sorry, again, sorry, I shouldn't, actually, this is corroboration. I'm pointing to the wrong word. The rest of the word I should be pointing to. The right word I should be pointing to is is it still on the screen? Yes. Appraisal, all right. So, right. So Popper's form of appraisal is corroboration. This is I guess he says that this was supposed to be neutral. But then he was going to tell you what, yeah, it's actually, I'm not sure I understand. This is in 248 note 1. It's probably not important, but that's the note where he talks about the translation issue. Okay. Yeah, I mean, no, I guess what it is, it's neutral because he's going to try out different proposals for what it might be. If it's not justificationism, what kind of corroboration could work here? And he says, well, it can't just be that that we give it a positive appraisal if it hasn't ever been falsified, because like infinitely many theories have never been falsified. Um, so the first proposal is the next proposal is, this is on page 265. A theory is to be accorded a positive degree of corroboration if it is compatible with the accepted basic statements, and if, in addition, a non-empty subclass of these basic statements is derivable from the theory in conjunction with the other accepted basic statements. Right? So the second proposal for what corroboration is going to mean is that you can use the theory to derive new statements from old ones. Correctly derive new statements from old ones. So as Popper points out there in a footnote, this is really the same, this is his demarcation criteria, is that a scientific theory allows you to derive, an empirical theory allows you to derive predictions from initial conditions. but that means like allows you to derive predictions from possible initial conditions. Here, the view would be that the theory, that's what makes it empirical, according to Popper. Here, the view would be that the theory is corroborated if it actually has made predictions based on some initial conditions that came out right. So Popper says that's actually good as far as it goes. I mean, that's a way of saying that the theory is falsifiable, but it hasn't been falsified. But that doesn't allow us to say that some theories are better corroborated than others. It's still going to be the case that all the theories that, well, yeah, so maybe I said the wrong thing before. I'm sorry. The first thing that the theory is corroborated if it hasn't been falsified doesn't rule out metaphysical theories that make no empirical predictions. The second one rules them out, but it doesn't tell you how to decide between the infinite number of theories that haven't been falsified, that made predictions and haven't been falsified. So instead, Hopper says, we have to have used it to make, first of all, there's a number of factors here that lead to the corroboration being, degree of corroboration being better. It has to be like the more testable it is, then the higher degree of corroboration it will get. Everything else being equal. So testable means simple, means again, like it makes more predictions per unit theory. So in other words, like a theory that just consists of like describing every situation we've ever seen in such a way as like to treat some parts of it as initial conditions and other parts as predictions. So it's really, really long. It's not falsified, but that's not a highly falsifiable theory. It's not simple. It doesn't predict anything except what we've actually seen, for one thing, right? It doesn't predict anything new. And second of all, the degree of corroboration is going to depend on the severity of tests that have been sincerely applied to the theory. So we have to actually have been trying to test this theory and trying to test it sincerely. Meaning we were willing to accept a negative answer. And it passed. So that's going to increase the degree of corroboration. And finally, it's going to depend on what other theories are under consideration. So it's not going to depend on what other possible theories there are, because there's infinitely many of those. It's going to depend on what other theories have actually been proposed. So, for example, if a simpler superseding theory has been proposed, then the degree of corroboration of the old theory by itself is going to go down. You might think this contradicts this picture, but I think it doesn't, because again, what's going to increase is the corroboration of this theory regarded as a limiting case of the bigger theory. But the theory by itself now is regarded as less corroborated just because a simpler theory that would account for it has been proposed. Like even before we start testing the simpler theory, that already lowers the degree of corroboration of the old theory. And like that last part where we ask what other theories are on the table and we have a way of preferring one over the other is what leads to what Popper calls quasi-induction. That is a progress of scientific theories that looks like what the inductivist expects, right? Because when we have, again, when we have the old theory, it's, we normally, remember, we have to guess when to accept a falsifying hypothesis. Sometimes we may guess that we have to accept a falsifying hypothesis when we have no other theories on the table, and then we just won't know what to say. Like we were wrong and we don't know what the world's like anymore. We should hope that won't happen. We normally though, because we hope that won't happen, we normally get around to accepting the falsifying hypothesis at a time when there is another theory on the table that we're going to prefer to the old theory if the falsification goes through. And because of the rules of what counts as higher degree of corroboration here, we're going to prefer the theory that's more corroborated, right? So because of the rules that what counts as the higher degree of corroboration here, we're going to prefer a theory that, again, more or less implies all the successes of the old theory, but is simpler and makes more falsifiable predictions. So we're going to prefer a theory that has the old theory as a special case and, includes more. So we're going to get that exact same progress of, and this new theory, including the special case, are going to be better corroborated than the old theory was. They're simpler. They passed all the tests that the old theory passed, plus new tests. I mean, like in particular, they have to give the right prediction in the case of the falsifying hypothesis. That was a test that the old theory failed, but the new theory is going to have to explain that. It's going to have to explain it again by saying that it was outside the realm of old theory. Or at least we're going to prefer a theory that does that. Right? So it's going to say, oh, yeah, the old theory was never tested in Australia. It should have just been used as a theory of swans, not in Australia. Right? Now the new theory predicts the color of swans everywhere. But again, it's supposed to be, we're looking for one that's simpler than the old theory. So it's not just going to be swans are white everywhere except Australia where they're black. That's not simpler than the old theory. It doesn't make more falsifiable predictions than the old theory, right? We're going to want some kind of unified theory of swan color. I hope this goes without saying, like, we don't have biological theories like this. Swan color is a product of natural selection, which means randomness. All right. But okay. So oops, I'm almost out of time. In fact, I really am out of time. I guess, yeah, all I'll say is, so it might seem like this is just induction back again. I mean, we're accepting basically the same theories, but for different reasons. But Popper thinks that when you look in the context of the other problems, and then you connect it to ethical and political considerations, you'll see that this is really quite different. That the old version has us accepting these new theories because of what has happened to us. We've accumulated more and more experiences. Again, I would like to talk about the difference in Erlebnis and Erfahrung, but again, I haven't left myself time for it, so I won't. Whereas Popper's new theory says, and this is a quote from page 280, we do not stumble upon our experiences. That's Erfahrungen. Nor do we let them flow over us like a stream. In German, it says, wie einen Strom von Erlebnissen, right? So we don't stumble upon our experience in the active sense of a way of learning things. We don't stumble upon that. They don't flow over us like a stream of things we experience. Rather, and he goes on, and this is an allusion to Kant, it is we who always formulate the questions to put to nature. Right? Like we're always taking a risk, putting our theory on the line, taking responsibility for it because it's our guess. So like Popper thinks that means that science is going to require freedom. Whereas the other version makes it look like science is something passive. And then as far as the answer to these things, I'll just say briefly, like, so Popper says, I think there are real regularities in nature. We all think that. Well, so maybe it's okay. I don't know. I think there are real regularities in nature. As far as why we believe that our theories are reliable, we believe it for some reason, but not rationally, because belief is never rational. Why is it rational to act on them? Well, because we believe them. So right at this point, I say that Popper is not trying to get you to not believe them. And furthermore, it's not clear whether this is an exception to the rule that belief is always irrational. But the answer, when you put it together, is something like this. For sure, we're going to believe that our theories that we arrive at in this procedure are true. We can't help but believe some theories are true. The question is, what rules should we adopt to like behave rationally in that situation where we have these irrational beliefs? And Popper's answer is, as I said to begin with about Popper, we should adopt the rules that don't leave us stuck, that don't leave us dogmatists. So we're going to believe something, we're going to act on it, but maybe in the end we must believe that there's some reason why that works. But meanwhile, the way we should act is treat these theories as guesses and try to test them. All right. I'm sorry. Oh boy, I went over for 5 minutes. That's not good. I'll see you next week.